Well, a warm welcome to anyone joining. Thank you for being here. Go ahead and get yourself ready with a notebook, grab a pencil or pen. Whatever you choose to write with is fine. This is math from the void. Math coming at you pretty much out of nowhere. And today we have some algebra recap for those of you who are in Algebra 2. This is a recap on functions, transformations of functions, just a brief segment of function work. We're going to take a look at how we use a transformation with a point. We're also going to take a look at piecewise function and how to evaluate it at some different locations. Go ahead and give yourself about 12 minutes or so. Try to work this out for yourself first, maybe 15 minutes if you need it. And then when you're ready, unpause the video. Come on back. See how we did it here. Okay, let's get started. Now I'm going to move some stuff. I'm going to make some space. So we have plenty of space for these problems. And let's get started here. So given that the point 1, 10 is on f of x, what does this mean, by the way? This means that f of 1 equals 10. So given that fact, let's find the transformed point on this new function. So this function is made up of f of x, but there's been some transformations to it. It might be shifted down, it might be shifted up, it might be shifted left, or it might be shifted right. It might be flipped, it might be compressed, stretched, all of these different things which we can do called transformations. And in order to use the point that we have here, we need this input to be equal to 1, because we only know f of 1 equals 10. So if we can turn this into f of 1, we'll be in pretty good shape. How do we turn that into a 1, though? We simply make an equation that says the inside, negative 3x plus 5, is equals to 1. And we can solve this. What does solving this do, though? Let's make a note of that. By solving this equation, we are finding which x value on the new transformed function corresponds to x equals 1 on the old original function. So that's what we're doing here. So let's continue. We're going to say that negative 3x is equals to negative 4, and therefore x equals negative 4 divided by negative 3. Be careful, because a negative divided by a negative is a positive. So that means 4/3 on the new function is going to somehow be related to x equals 1 on the original function. Okay, now if we use this function value, what do we get for the y? The y would turn into f of negative 3 times, let's put in the 4/3 just to show that it's going to work out nicely, plus 5 minus 9. And you'll see that this turns into, as we designed it this way, we solved what would make this perfectly turn into a 1. So this is going to turn into negative 12 over 3 plus 5, which of course, since negative 12 over 3 is just negative 4, we're going to call this negative 4 plus 5. And inside of the function now, as desired, we have f of 1, which we know is equals to 10. So the transformed point is 4/3, comma, negative 4. Okay? We're going to get an opportunity to do that again with a little bit more abstract of a value. So what this means here, the point c comma d is on f of x. That means that if I plug c into the function, I get a value of d. And in order to find the transformed point, I want this to be equals to c. That way I can use f of c. So let's set that up. It's going to be a little tougher because we have variables. We have two variables. We don't just have a value, a number. Still just solve for x. we want to find the x value that's going to get us to the same spot as c. And we can do that carefully by adding 2 on both sides. Multiply both sides by 4, and we get negative 1x equals 4c plus 8. And since that's a negative, we just want x, not negative x. This is negative 4c minus 8. Now, I know that doesn't look like a nice number, but whatever c is, that's just some number. And let's imagine what would happen if we plug that x value in. So we're going to get y equals negative f of negative 1/4 of x. Let's plug in the x. Negative 4c minus 8 minus 2. Now, technically, at this step, you could just turn all of this into a c, but I'd rather plug in the x to show you that we're going to end up with c on the inside. So let's multiply by negative 1/4 inside, and that's going to give us positive 1c and positive 2. So clearly this is going to turn into f of c on the inside, and we know that f of c equals d. So we can maybe write this as negative d plus 5 or 5 minus d. So the point that we have here, it is a little bit weirder looking. The x value is negative 4c minus 8, and the y value is 5 minus d. Okay, great. Now the last problem here involves a piecewise function. And the thing about piecewise functions, you'll notice that there's like several different equations, several different functions. There's 4 pieces to this function. And what's really important is this thing on the right. You'll see commas there for each piece. And that's because on the right side, we're basically writing the domain of each piece. These pieces are not going to extend forever. So this first piece just means it's valid up to negative 1, not including. I'll put not inclusive. The second piece of the function, it says x equals negative 1. This is only valid at x equals negative 1. So if I need to know what's the function value at x equals negative 1, I would be using this piece to determine that. So this piece is valid between x equals negative 1 and x equals 3, not inclusive. So if I want to know what is f of negative 1, I don't use this piece. It's not inclusive. If I want to know what f of negative 1 is, I use this piece. It's valid at x equals negative 1. If I want to know the function at something less than negative 1, then I'll use this piece. And if I want to know something that's a function value when x is greater than 3, I'll be using the bottom piece. So this is valid after, which basically means like greater than x equals 3. So if x is bigger than 3, the function value is just equals to 9. Okay. Let's take a look at this here. So the first part is asking, what is f of 3? F of 3. Well, we're not going to use this piece because 3 is not less than negative 1. We're not going to use this piece because 3 is not equals to negative 1. We're not going to use this piece because this is only between negative 1 and 3, not including x equals 3. And the bottom piece is only when x is greater than 3. So we have no definition. We have no value. Let me move some of these. We have no possible value to give for f of 3. It's undefined, meaning there's no description on what we need to do when x equals 3. Let's look at f of negative 1. This one's going to use the second piece because it's telling us that this piece is valid when x equals negative 1. So we sort of plug negative 1 in here. There's not an x to plug it into, so it's just going to equal 4. Those ones are really easy. They don't have an x to plug into. So if we're in this domain, at x equals -1, the y value is simply just 4, no work required. Let's take a look at -15. This one is finally interesting because -15 is obviously less than -1. So we have to use this piece to get its function value. How do we use the piece exactly? We plug the x value in. So let's see what that's going to look like. There we go. And of course, this is equal to negative absolute value of -7. Well, the absolute value of -7 is just 7, but since there's a negative in front of that, our answer will be -4. Okay? All right, we're moving now. Let's look at f of 2. The input is 2, so we look at our domains to see which piece we're going to use. 2 is not less than -1. 2 is not equals to -1. 2 is between -1 and 3, so we're going to use that piece to determine its function value. So let's plug that into the piece that says x minus 2 squared. We're plugging a 2 in for the x. And of course, 2 minus 2 is just 0, so 0 squared is 0. That's our function value at 2. All right, for the last two parts, we're going to have to get a little bit layered here because we have multiple layers of the function. See, we have f of. Well, in order to plug this in, we work from the inside out. The reason why is because in order to do this f of something, we need to know what f of 4 is. We can't plug anything into the f function if we don't know what we're plugging in. So we start off with the inside portion, which says to plug 4 into the f. So let's go ahead and do that. Let's say f of 4. Which piece are we going to use? In fact, have we done f of 4 yet? I don't think we have. F of 4, since 4 is greater than 3, we're just going to use this piece. It's equal to 9. Pretty easy there. And now that we know that's equal to 9, this just becomes f of 9. And again, since our input value of 9 is greater than 3, we're going to use this piece of the function again. So f of 9 is just 9. Because the x value tells us which piece to use, the fourth piece. And that piece says, no matter what your x is, as long as it's greater than 3, the y value is 9. Let's take a look at the last one here. So in order to figure out this, we need to know what f of -11 is. So first we're going to say f of -11. Which piece are we using for that? We have to use the first piece where x is less than -1 because -11 for sure is less than -1. So let's use this piece. It's going to be equals to the absolute value of -11 plus 8 and then plus 3. This, of course, will be a -3 in the absolute value, but since the absolute value of -3 is a positive, we'll switch that. And don't forget that there's a negative in front. So even though the absolute value becomes positive, there's a negative in front of that, which turns it back to negative. Little flip-flop action there. And then we're going to add 3. So the result is 0. Okay, so that's how we use piecewise functions, carefully considering the domain to help us out. There are more topics to cover when it comes to transformations of functions, but I think these are some of the tougher problems that don't involve graphs. So it's good practice reminding yourselves that using a point on the original function can help us find the transformed point on a more complicated equation that involves the function f of x. All right, I think that's enough blab out of me. I'll see you guys next time.